Every year, hundreds of electrical engineering students, almost all of them, have these three questions in their mind. One, will there be still the core engineering jobs when AI take over? Second, can someone tier 2 or tier 3 engineering college can build a real hardware company inside India? And third, do I really need to be from IIT or NIT to do that research? What matters? If you ask me today, my answer is firmly yes, but only if you plan your engineering degree like the engineer plans the circuit, with intention, not accident. Today I am going to give you 4-year roadmap for your electrical engineering journey that I have found out by research for my own branch selection. So stay till the end, because year 4 is the year where most of the students lose the track without realizing it. Let's be honest, where we stand today, the core electrical sector in India, like power generation, transmission, distribution and motor drives and renewable integration, is not shrinking, it's transforming. Electric vehicles, smart grids, battery storage, green hydrogen and semiconductor fabrication, all of this need electrical engineers who actually understands the power system and also can speak the language of software and artificial intelligence. This is the point what most of the students miss. AI is not going to replace the electrical engineer. It is surely going to replace them who refuse to learn beyond the syllabus. The engineer who combines strong fundamentals in machines, power system and control theory with data-driven thinking, predictive maintenance, digital twins, smart grids, grid optimization algorithms, that engineer is most valuable today than any point in last 3 decades. So your goal for 4 years is to become that hybrid engineer. So let's build year by year. Year 1 is where most of the students lose the track or panic too early. Neither of this is correct. First priority, master the fundamental of circuit theory, electromagnetics, electronics and engineering mathematics. Do not consider these subjects as you have to just clear it, because every advanced sector from power system to control system to power electronics is built directly on these core 4 pillars. If your fundamentals are weak, no coding bootcamp will save you later. Second, in parallel, not after, start one small hands-on project. Build a simple inverter or a solar controller or a simple line following robot. Your goal isn't innovation, your goal is to get used to breadboard, datasheet and multimeters. Third, learn one programming language, most likely Python, not for the coding but for the simulation, data analysis and machine learning that is used in the electrical engineering. Fourth, this is most important, get used to with MATLAB or Simulink or Python free open source libraries for control systems. Simulation is the thing where modern engineers visualize before they build. By end of year 1, you should be able to explain from first principle how the transformers work and also have built one hands-on project. Year 2 is about choosing the lane while keeping your options in electrical engineering open. 3 main broad tracks dominate the core industry hiring: power systems, power electronics and drive, and control and instrumentation. Add 4th emerging track, electrical systems for electric vehicles and renewable energy, which barely existed a decade ago and is now doing mass hirings. Pick one of them on basis of your genuine interest, not on the basis of the placement statistics. Take electives properly, join a lab under professor and also ask them to assist on the project that is currently ongoing under him. This is also year you will be layering the AI literacy. You do not need a full machine learning degree for it. You need to know how neural networks and optimization algorithms are used in the predictive maintenance of motors, fault detection in transmission lines and load forecasting in smart grids. Take one course on Coursera or NPTEL, specifically mentioning machine learning for power systems. Simultaneously, start building your second project bigger than year one. For example, a load forecasting model using real open source grid data or working battery management system. Document it properly, host the code on the GitHub, and also make a blog post or a YouTube video explaining how did you do it. Why? Because this single habit, documenting your work publicly, is what separates the student who get noticed by the recruiters and professors abroad from student who don't. Year 3 is the year of depth and visibility, and this is the time when the seed of $1 billion business gets planted if it is your goal. For depth, at least one advanced elective in your chosen track. Pair it with a rigorous project that can be plausibly published or submitting to the student paper competition. If you are interested in power electronic, build a working prototype of bidirectional converter for electric vehicle charging. If your interest is grid, work on the demand response simulation based on the real data. For visibility, this year you have to do the internship, not for the stipend but for the exposure. Target the core PSUs like NTPC, BHEL, Power Grid and NHPC for the deep system exposure, or target private sector companies that are working on EV powertrains, battery management systems or grid tech softwares, where you will actually see AI and electrical engineering, how they are fused in production, not just in the theory. If entrepreneurship is your goal, you have to find some problem, not like renewable energy is important, but some specific like rural microgrids lack affordable fault detection hardware. Start talking to potential users, build a rough prototype, start applying for the incubation cell inside your institute. You do not need to quit your degree right now to build something. You need to start validating problem right now while you have zero pressure and maximum resources like lab, mentors and time. If research is your goal, then this is the time you reach out to the professor in India and abroad whose research paper you actually read. Attach your year 2 project, because a well documented undergraduate project opens the more door than a generic resume. Year 4 is the time of conversion. All the efforts and preparation you made in 3 years, you have to bring it to an outcome. And here's the time when you make a horrible mistake and no one will notice it. Students treat year 4 as a placement season and stop building. That is exactly wrong, because recruiters, funding committees and professors abroad are actively looking for the most recent work you have done. If your target is entrepreneurship, you have to move from a prototype to real product for which customer can actually pay for, even at a small scale, because one pilot paying customer is more better than 10 polished slides. Apply for pre-incubation funding. Use your college business incubation center. If it isn't there, then search for nearby one, because they are not restricted for your own campus. If your target is core sector job, then your capstone project should be the single strongest item on your resume. Make it demonstrably relevant for the modern industry. A control algorithm that also uses data-driven prediction, for instance. Practice it explaining in 60 seconds and then in 5 minutes, because it will be asked in interviews. If your target is research abroad or in the premier Indian institute, apply broadly, not just for the institute, not just for the 5 name everyone knows. Many excellent labs in Germany, UK, US, France, Switzerland and premier Indian institute like IISc, IIT Madras, IIT Bombay, IIT Delhi and IISc actively look for the undergraduate projects. Clear recommendation from the professors over the pedigree alone. A focused, well executed final year thesis with one preprint or conference submission will outweigh the name of the college you are in almost every time. Now, for everyone who is not from IITs, NITs or any top tier college, everything I have described till now works for everyone regardless of your college. Here's the truth. Labs, professors, funding committees and recruiters always look for your projects than the college logo. What the top institute genuinely offer is a high density of the peer that are dedicated to build the thing, professors which are more accessible in person and more recruiters visiting your campus. You can manufacture the density yourself. Participate or start a technical club that focuses on the power electronics or renewable energy. Participate in the national level competitions like Smart India Hackathon, Solar Decathlon India and IEEE Student Paper Contest. These are open for everyone regardless of their college, and this is where most of the recruiters and professors from the top institutes actually notice the talent outside. So that was the video. I have shared all the things which I have researched to make my branch selection decision more wiser and more strategic, and I hope that will help all of you also. Signing off, Politosurgeon this side. Like, share and subscribe.